Good morning, good afternoon, good day. My name is Tim Gergis. I'm the Director of Product Management for looking after the mesh geometry and morphing side. Today we've got Pritam and Celine, and we're going to be going through the 2023 workflows and implementations into into HyperMesh, I think it's called now. So we'll jump in. So the first thing we're going to cover today are the changes to FE geometry and the ribbon layout. If you've had a chance to look at any of the 23, you'll notice that we've shuffled the ribbons. So we're going to talk a bit about the philosophy of what we've done and why, as well as what's been implemented from a geometry side and sort of an FE geometry side. This is really what we're trying to aim for here. We're trying to kind of envisage a future where mesh and geometry are interchangeable. This is really what we're trying to go for. This is why this is kind of the philosophy of what we've done for the ribbon changes. This is the philosophy of where we're coming from the changes that we've made to FE geometry as well as CAD geom in 23. We've in the current state, HyperMesh's initial implementation of FE geometry with the mid-mesh tool supported mostly only 2D geometries with a very direct association between mesh and geometry. We've listened to your feedback. We've listened to customer feedback. We understand that this limitation constrained the user experience and not only that, it only applied to FE geometry. So we had a very different relationship between what was happening in CAD geometries as well as what was happening in FE geoms. So what we're trying to do now is effectively, and what we have done is unify the same feel between mesh geom and FE geometry. So what we've done is we've broadened the implementation of FE geometry. We now support all geom types, 1Ds, 2Ds, 3Ds. We've added new enhancements for association, which we'll be covering very shortly. And then we've changed the ribbon layout to kind of reflect this change. And it's really allowed us to effectively embed multiple tools into the same, what historically was many different tools that were doing the same operation into the same tool with just different selections. And this will effectively help us blur the line between what is geometry and what is a mesh tool into effectively what is a topology tool, hence the title of today's session. The improved association rules will allow for greater flexibility in editing. It'll make us more accessible to a wider range of users. It'll allow us to consolidate the individual tools between what is a geometry tool and a meshing tool into a single set of topology tools. And it'll also effectively help the user experience find what they're trying to do, as it will be effectively operation driven. And then within the operation, they can then specify what they want to work on. But ideally, and effectively what we're pushing for is that should be a geometry operation. So instead of a 1D, a geometry mesh elements layout, we now have a topology, which is all the common tools between mesh and geometry. We then have the 1D tools, and this is, I think there's still some migrations when we took these screenshots. So there are a couple of other tools that are effectively being migrated into 1D as well. We have the 2D tools. So these are all the planar 2D operations, all the meshing. It allows us to put mid-surface, mid-mesh, map thickness, and rebuild effectively together. Edit elements. We're also going to put edit elements into the 3D as well, just as there's the layer split and layer merge and all those layer operations are available in edit elements now. That'll also be available in the 3D tools. So it's a bit of a reshuffle of what we've known historically. It's almost a step back to where we were before. So migrating customers in the same set of look and feel from what they're historically used to. It should feel a bit more familiar to them, but it also allows us to kind of step forward from here as well. So the enhancer, to better illustrate the flexibility of what we've done, we're going to go through a quick demo of this coupled topology behaviors that we've introduced. Now these work for both CAD geometry as well as FE geometry. Now FE geometry, historically, if you isolated, you couldn't isolate down to a single element associated to the surface. You've got the whole surface and all the elements on that surface. So we've removed that limitation. Now, as we go through, if I isolate this propeller, and we're going to select some elements on this propeller, and we're going to isolate. Now, in this case, the decoupled behavior, as you would currently expect, as always has historically, you only get the elements. If you turn the coupled behavior on, we show the supporting geometry under that solid. So in this case, you see the solid associated with those elements. If I isolate the solid itself, you get all the elements associated to the solid. And if we turn that coupled behavior back off again and I isolate the solid, you get only the solid. So in this way, you get the behaviors that effectively that was available for FE geometry historically. So you could get the supported surface associated to your mesh if you want. And now you can turn that off if you don't want, which is a very legacy HyperMesh sort of approach. But it also allows us, and this will also work for CAD geometries as well. So it really, with this coupled decoupled behavior on, it allows us to really have more of a sort of coupled mesh geom approach, which is something that we get from a lot of customers coming into HyperMesh from other programs and other softwares. So what this looks like effectively, what can be done now in like in the session is, in this case, we want to tie these stringers into this skin. We can go through the process of selecting the lines associated to the stringers, selecting the surfaces associated to that mesh, and then this effectively will imprint and tie those topologies together. And that's it. And we see the connectivity in the topology as well. So it's really just trying to give the customers the most amount of tools available to them to get the best results they're looking for in the simplest sort of direction. And at that, I'm going to hand it over to Pritam to discuss, and Salim to go through the migrations, the other migrations that have come into 23 from the panels.
Thank you, Tim, for laying out the foundation. Hello, everybody. This is Pritam Deshpande. I am the program manager for geometry and meshing. So today I will go through some of the details from the standpoint of what we are covering from panel migrations. Since the panel will be taken out, we want to make sure all the functionality is provided in the new tools as well. So starting off in the sketch tool, the main enhancement that been requested from the field was to be able to see the sketch graphics on top of your current model, and that's been added. So it's one graphics now. So you can easily select a plane or a surface from your existing model as a reference, and actually that can be seen in the background. So just like Inspire, so it becomes very easy for the users to work with Sketch. And we are also going to turn on the legacy behavior, where it was taking the sketch tools into a different graphics mode where you don't see your current model for reference. And this is mainly to make sure that all of the 1D kind of, hyper beam type of workflows are supported, where you don't really want any distraction from your current model, and you can just work in the solely the sketch graphics. So give it a try. I think this is definitely a great enhancement, and it will also open up a lot of usage for our tools, since the reference geometry can be seen in the background. Now coming back to the core geometry tools that have been migrated from the panels, points and nodes. So we now are supporting extract at intersection. So creation of points and nodes, as you can see from the animation here. We support that under points and nodes and extract option. So you will see that there is a method added called as extract nodes or points at intersection, and these intersections that were supported in the panels are been migrated. So it could be lines versus lines or lines versus points, sorry, lines versus planes or line versus surfaces and so on. So all of these, I haven't put all the videos, but just this is just a sample video that I've been showing, but we are supporting all the options here that were supported before. The next one is the extraction of lines at intersections. So similar to points and nodes, we also had extraction of the lines um, between two surface intersections or a surface and a plane or even elements as shown in these videos. There also an extraction of lines with two plane intersections. So that has been added under lines and a method called extract at intersection. This request also came from field, and this is to enable the merging of the solid. So we had merged solids by removing a surface. So for example, if you have a solid which has been split into two and you will have a shared surface. So all you really care about is deleting that shared surface. This may not be uh, very time consuming Boolean operation. For example, earlier we had supported this through Boolean and Boolean can still do that, but it could take some time. And if you want to just remove scratch surfaces between the solids or just would like to select only few surfaces that you want to remove, then this was a beneficial tool, and now we have migrated it under Boolean, but as one of the options called as merge solid. So this will be much more quicker than actual combine Boolean operation, and we support the same kind of functionality that was always there in the merge solids. Detach elements, as Tim has mentioned, we are trying to consolidate some of the tools and also making sure that these tools for elements and geometry reside in only one tool with a selection of geometry and elements. So we had detach solids previously. Now we have added element selector to it and migrated all the detach elements functionality to this particular tool. So here you can see that detach from is also available and detach from wall is also available as one of the methods. So depending on your secondary tool or secondary selection, it will trigger whether you are detaching it from or detaching it from wall. That is that you can see it from here on the videos. Offset distance and you can see here that actual tool itself, some of the micro dialog options show that how we are supporting it. The other major tools that have been migrated is under validate is the edges and faces or an equivalence. So earlier what we used to have is edges and faces, and we also had the equivalence kind of you know not hidden because now that everybody knows how legacy functions are, but it was still under edges and faces. So what we have done here is that we have separated edges and faces context, and we have also provided an equivalence which will give you a complete view of the equivalence function itself. So what has been free, it creates a legend for you. There's a model tool that is supported, as you can see from the video itself, for the edges here. And in edges, what we have done is all this functionality except for the equivalence is provided. So if people want to see and extract edges, they can do that. Um, Sometimes people just want to see or review their model. So through the review, we have provided this as a graphical way of visualization of the edges. So none of the components will be created in this graphics mode. And once you kind of click on the play button, that's when the actual component will be created. And what we have also modified here is that individual parts, so it kind of follows the part hierarchy. So if once you create these components as an edge component, it will go into the under the part that it has been extracted from. So that is something new that you will see, and it's also beneficial from the organization standpoint. And you can see from the video, it takes you to the model tool. It also has plus and minus buttons to add the element view that is right next to the edges to enable better visualization and the model diagnostics. Now the same exact thing has been also done for the faces context. As you can see, you can extract faces just visually. Um, you can review them. You can also find attached elements or adjacent elements to those. And you can click on play button to actually create a face component. Again, that will be migrated under the relevant part. Under the equivalence function, we have a global equivalencing. So basically one click solution. So you can select all of your elements. It will create a micro dialog and you can visualize where you need equivalencing and just click on equivalence. If you want or are interested in more deep dive into what exactly or where and what you want to include in your equivalencing, before you actually equivalence, you have an option of actual review, which gives you a model tool. Again, the same functionality of displaying adjacent elements is available for better visualization. It also creates legends, so you can see that you can see different colors for what it finds out as individual nodes or line of nodes and so on. So it becomes much more easier for people to visualize and actually carry out the equivalence function. Some of the other panel migration items are extracting lines or creating lines by dragging nodes. That's been provided under lines and as a drag nodes functionality. There is also coming from field that we want to make sure that we provide or support creation of circle by 3 nodes. So what we have done is we have changed this a little bit, since I know that not a lot of people like to see certain things on control and shift. So now we have explicitly added methods where what panel also supported is as creating of circles by center and radius, by 2 points and by 3 points. So that way all the functionality that's been offered, and also you can pick and choose. So there are no the the mouse functionalities that you would miss otherwise. And it was also needed since we had to add another method to it. It was not possible to do it on with the current workflow with control and shift. So there becomes too many combinations and it gets confusing. So we have cleaned that a bit and make sure that 3 different distinct methods are available for the creation. Other simple functionality is splitting line at joins. So for example, if you have lines that you actually had combined at several locations and you would like to visualize it, you can actually go to the split parametric option, and for the free lines, you can select a line. It will show you the locations where you had combined it before, and you can select and choose those or split the lines into the original lines. Another panel migration item, and really a key one, which completes our legend functionality, is now that we support 1D elements as well. You know that we had added 3D elements to our legend. So this complete our legend functionality. We also are now supporting 1D into our criteria editor also, since that the criteria file itself drives the legend. So you can see that from the panel standpoint, we had 1D, 2D, 3D, and all the element quality mentioned, which are shown as tab into legend. So 1D, 2D, and 3D. And based on the selection, it will have criteria and QI range, for 2D, for example. So for 1D, you can see that we support the size, the like minimum and maximum size and time step, which is what it was before. And it's been default off since it's usually um, taken care by the or relevant in the crash profile. We also had some other functionalities under 1D, which is making sure the kind of the meshing checks, I would say. So those have been migrated into model checker, and the actual length or the size have been migrated into legend, because that's what really makes sense, from the where each functionality resides. Now, as you know, Tim has mentioned some of the higher level goals, or where we are, or vision where we are headed to. This is another functionality where we are trying to make all the tools talk to each other, make sure that there's kind of one database where things are stored and can be used into different mesh controls. So you can see, excuse me, an example here where I'm basically launching a batch mesher, and once the batch meshing is complete for this particular part, it's creating all the features by default, which it has been recognized. This is a key uh, for to make sure that all of these features can be used into mesh controls, going forward. So there is a two-way communication between our features tool, which was, kind of not talking to batch mesher before, and batch mesher doing similar kind of things, but would not write out into the HyperMesh database file all those features that it has been recognized. So this is just one step is where we are allowing the batch mesher to create these features. You can see that now that batch mesher has written all these feature entities, you can visualize them and through the legends, because now the features, when you launch it, it will also show all those entities that has been created by batch mesher. So it's definitely going towards making sure that we create these not in silos but together. And when we actually move to creation of the representation control and mesh controls, all these things will be put together, um, and which will be very useful. Another item is the line mesh item. Um, this is still been worked on as we speak. The basic functionality of providing line mesh is available, and we are working on providing it and assigning the properties as well. So you can see from the small video on how it's been, how we can provide the biasing as well as the element density and size and so on. And you can see here that you can actually assign the beam sections or the properties right up front through the controls, and you can also visualize it right here. That's all from my side. I would like Salim to take over from this, and he'll take you through the next section.
Thank you, Pritam.
Was
Hello,
muted.
everyone. My name is Salim, and I'll be taking through some of the meshing and morphing panel migration items. So to start with, I'll start with spin panel migration. Basically, we have allowed elements and facet selections in the revolve tool, which is under topology now, which enables us to, which used to only use for creating 2D mesh earlier, geometry along with mesh. Now it will also enable us to create solid elements. Basically, I can select 2D elements and then I can revolve along an axis to create the solid element, or I can select faces of 3D element to create solid elements. So this is migrated to revolve tool now, which was previously called as spin. Moving to the next item, so we have also migrated normals panel to a context workflow, wherein we had this normal icon under 2D, which used to point to the panels. Now it enables us to going through the context workflow. Now we have ensured more consistency between element and surface normals. Element normal is always aligned with the surface normal, especially when we are in the normals context. So basically, which makes us, to deal with more of a surfaces rather than going off a element unless it is an unassociated mesh. For example, if I want to adjust FE geometry, I would go to surface selection and then I can adjust that with respect to an element or orientation direction, or I can also reverse a surface. So which will also reverse the normals of the elements. So it will always ensure the surface is always aligned with the elements. Suppose there's unassociated mesh which is not associated to any geometry, then we allow the element selection as well, where user can select its elements and then adjust or reverse the normals of that. So just a note of that, we do not allow elements if they are associated to geometry to be selected because as I said, the obvious reason, we do not want to have the elements normals inconsistent with the surface normals. So going to the next item. We have also migrated mesh edit. Uh, Now, mesh edit to the imprint tool, which is under 2D, which was only used for the geometrical imprint. Now we also allow the mesh imprint for that. Basically, I can select the node list or element and I can imprint onto the mesh. It can also be an unassociated mesh or an FE geometry. So all of the other options like create patch, or if I just want to move the source to the target, or if I just want to imprint the node or keep the mesh pattern same between source and target. So all of those use cases can be handled via mesh imprint. So basically, mesh imprint and geometry imprint are consolidated to an imprint tool, which can be found under 2D now. Okay, so going further, uh, there are some enhancements that we have done with respect to the mid-mesh tool. We have improved the performance for mid-mesh extraction, especially those are like rail models, extruded models, so which are larger in the dimension compared to its cross section. So there has been extensive work for the improvement of the performance, nearly about 40 to 65% of improvement you can see on those models. We have also added tria meshing option for mid-mesh extraction, and now all of the editing tools like imprint or when we are doing node to node split to obey the preference FE geometry topology revision option, which were not doing before. It was by default remesh. Now, depending on the preference, if it is set to remesh, rebuild, or keep mesh, depending on number of layers, all of these editing tools are configured for that. So, going further, some of the miscellaneous enhancements that we have worked. So as a panel migration item. So for the hex tool, we have added multiple guide selection. Earlier, it was only the single guide. For example, if I'm using line, I'll not be able to use any of the other guides. And so for that, we have allowed now the multiple guide selection. For example, I can now use lines, nodes, facets, surfaces, elements all together. If that is allowing me to give a good mesh. So Hex tool supports the mixed guide selections now. We have also enhanced the performance for rebuild, especially for the cases where there's a large assembly and I'm doing rebuild on a smaller portion. So that was taking more time. Especially here, there's a case where the mesh is connected with the other part, which is having the larger assembly. But I'm just doing a rebuild on a single part, and then it used to take me 59 seconds for this model, so which we bought to about 66 seconds. Where there is this other case, we have the similar part, similar assembly, but now the mesh is not connected with the other part, right? It used to take me 60 seconds before, and now it takes about 48 seconds. Now there is another case where the same part which I'm doing a rebuild on, number of elements would be the same, but I have deleted the rest of the models in the assembly. So in that case, it used to take 17 seconds. Now it takes about 10 seconds. So there is a improvement of about 60% when the mesh is connected and all of that. So we have done good improvements on the rebuild also. So this also, gives us more benefit when we are realizing the connectors on a smaller region, keeping the larger assembly on the realization when we are doing the tag. So these are some of the improvements on topology 1D, 2D, 3D. Now I'll just go through some of the morphing uh, panel migrations that we have got. So coming to the panel migration of the morphing, so with respect to the shapes context, now check smooth, auto shape, or create from loads have been migrated to the shapes which earlier were pointing to the panels. So now they can be accessed through the shape context, edit shape dialog, where on the right click, all these options comes up, especially the check smooth will enable us when there is already a shape created and we want to either check that or we want to smooth that. Auto shape and create from roads does not require that we'll need to have a shapes for that. We can just click right click on the edit shape dialog, then we can go ahead and create the shapes from that. So morph volumes, some of the morph volume based panels have also been migrated to the context workflow, especially when we are updating the morph volume. There is a shrink option or fit options. There is a tool for us to update the morph volumes or shrink them or fit them to the elements, or convert the morph volumes to the solid element, or vice versa, converting them solid element to the morph volumes. We have also migrated save and load morph volumes option as a satellite icon here, wherein you can select the morph volumes and save it, or you can load them. So these are some of the panel morphing panels. Those are migrated to the context workflow. Some of them have been migrated to controller workflow, especially the domain-based panels have been migrated to the controller workflow. Um, a domain update is one of that. We have migrated that to a controller workflow under morph pull down menu, and set biasing with respect to the handles. Those have been migrated to controller workflow as well. So some of these items, so I'll just go on a quick demo on the morphing. So if you see, there have been two contacts that I added under morph volume, string fit and uh, convert. So you can select any morph volume and you can string them, or you can also smooth that, select any of the face, and say you can alter the buffer values and then fit to the exact element selections around that. So if you go to convert, you can select any morph volume and then convert it to an element, or vice versa, as we spoke about it. So you can adjust the mid handles when we are converting, so that can be converted to morph volume. So there is also a satellite icon that we discussed. So we can select any morph volume and save at a given location, or we can also load it if it is already saved. Uh, Coming to some of the shapes, so on the right click, it will enable us to convert the loads to the shapes. So for example, here there is a load collector which I can pick and I can create shapes out of it. So once I exit the tool, we can see that has been converted to a shape. So I can also create auto shape. I can pick any handle, and then either I can go with an XYZ direction, or I can just go along a vector. I'll pick a vector, and then I can define the magnitude to that. I can create a shape out of it, and if I can just animate that. So these are some of the context workflows. Coming to the domain controller workflows. So here we have added update option, which enables us to fix the domain. For example, if I pick this domain, I can do a remesh of that. Basically, I can define my mesh size, my mesh type. Say I want to define as trias, so I can convert this squares into trias. So I can also do smooth and all of that. So all of the update of the domains can be done from this. So there's one more quick demo. I'll finish off with that. So normals is the one. So as there is a bit of change in the workflow, I thought it would be nice to go through that. So from the visualization toolbar, you will see normals mode now, which will give a good visualization of the normals from the elements or surfaces. So there is a legend which will indicate us what is positive and what is negative. Uh, there is also no normals context workflow. So just to give you a hint, adjust is allowed only for the geometry elements where you can pick the surfaces and you can define the reference elements and you can adjust them. Or you can also do an individual reverse of the surfaces. Then coming back to this is for the geometry that what we saw. Coming back to cat plus mesh, say if there is any inconsistency between the element and surfaces. So what we see here because of some legacy cases. So you can also adjust those elements. For example, I can pick the surfaces and say whatever the elements that are associated but not in line with the surface, I can adjust them, or I can also pick any surface and reverse them. So it will reverse all attach along with its elements so that everything is inconsistent. So with this, I'll just come to a conclusion of the presentation. Thank you. Thank you all.
Thanks, Salim. Just to add a couple of small things here, just to help sort of add to what Preetam mentioned and also what Salim has mentioned throughout the presentation. So one of the things you can use now in Sketch is if you do convert to FE geometry, you can actually then use that base FE geometry in Sketcher. So that'll also help in any of the sketches you want to do on a legacy deck. You can then use your effectively generate the geometry from the mesh directly and then use that geometry in Sketch. So it's some really good linked togethers there coming through from that.